FastMCP 3 implements version filtering through the VersionFilter transform, enabling precise control over component visibility based on semantic version constraints. This mechanism operates at the provider level, allowing servers to expose only specific version ranges of tools, resources, and prompts while maintaining backward compatibility. The upcoming code demonstrates how VersionFilter parameters, version GTE and version LT, define inclusive and exclusive version boundaries, respectively, to create targeted API surfaces. You'll observe how these constraints combine to form version ranges, with unversioned components remaining unaffected by the filtering logic.
Hash versions 3v1x and v2x. VersionFilter version LT equals 3, 0. Hash versions equals 2v2x and later. VersionFilter version JTE equals 2, 0. Hash versions in range 2, 0, 3 only v2x. VersionFilter version JTA equals 2, 0. Version LT equals 3, 0.
The version filter in FastMCP 3 provides a declarative way to control which component versions are exposed to clients. It operates through two optional parameters: version GTE greater than or equal, and version LT less than, which define inclusive lower bounds and exclusive upper bounds, respectively. This range-based filtering allows precise control over version exposure, whether you need all versions below 3, all versions from 2 onward, or a specific range like 2, 0, 3. The filter's design maintains backward compatibility while enabling versioned API surfaces. Unversioned components automatically pass through any filter, ensuring existing functionality remains available. This dual behavior prevents accidental hiding of unversioned components when filters are applied, though it enforces a strict rule: you cannot mix versioned and unversioned components with the same identifier. The framework raises a value error at registration time if this rule is violated, maintaining predictable behavior. Version filtering applies consistently across the entire server hierarchy, including mounted child servers. The parent server's version filter affects all components from mounted servers, with filtering handled at the provider level. This centralized approach simplifies version management in complex server architectures, allowing uniform version policies without requiring child servers to be aware of parent constraints. The filter operates on the version metadata while preserving namespacing, making it effective for both flat and hierarchical server structures. Let's break it down.
VersionFilter version LT equals 3, 0.
Creates a version filter that excludes any versions less than 3, effectively selecting only versions 3 and above. The filter uses the version LT parameter to specify the lower bound for version comparison.
Hash versions equals 2v2x and later. VersionFilter version JTE equals 2, 0.
Creates a version filter that matches versions greater than or equal to 2, effectively selecting all versions from 2 onwards, including any 2x releases. The filter uses the version GTE parameter set to 2 to establish this minimum version boundary.
VersionFilter version JTA equals 2, 0. Version LT equals 3, 0.
Creates a version filter that matches versions greater than or equal to 2 and less than 3. The filter will include any version from 2 up to, but not including 3. FastMCP 3's version filter provides a clean, declarative way to control API surface exposure through semantic version constraints. The version GTE and version LT parameters work together to define inclusive lower bounds and exclusive upper bounds, enabling precise version range targeting. Whether you're exposing all versions below 3, everything from 2 onward, or a specific range like 2, 0, 3, The filter handles it consistently across the entire server hierarchy, including mounted child servers, while maintaining backward compatibility by letting unversioned components pass through unaffected. The key insight is that this centralized version management operates at the provider level, simplifying complex server architectures without requiring child servers to be aware of parent constraints. The framework enforces strict rules to prevent mixing versioned and unversioned components with the same identifier, ensuring predictable behavior through early validation at registration time.
VersionFilter holds v20 tightly while pushing v30 away, yet claims to love only what it releases.